The 19th International Physics Olympiad Year 1988 IPHO. Problem 1. Maxwell's wheel. Theory. Introduction. A cylindrical wheel of uniform density, having the mass m equals 0.4 kg, the radius r equals 0.06 meters, and the thickness d equals 0.01 meter is suspended by means of two light strings of the same length from the ceiling. Each string is wound around the axle of the wheel. Like the strings, the mass of the axle is negligible. When the wheel is turned manually, the strings are wound up until the center of mass is raised 1 meter above the floor. If the wheel is allowed to move downward vertically under the pulling force of the gravity, the strings are unwound to the full length of the strings, and the wheel reaches the lowest point. The strings then begin to wound in the opposite sense, resulting in the wheel being raised upwards. Analyze and answer the following questions, assuming that the strings are in vertical position, and the points where the strings touch the axle are directly below their respective suspending points. See Figure 19.5. Questions. Question 1. Determine the angular speed of the wheel when the center of mass of the wheel covers the vertical distance s. Question 2. Determine the kinetic energy of the linear motion of the center of mass, e, r, after the wheel travels a distance s equals 0.5 meters, and calculate the ratio between e, r, and the energy in any other form, in this problem up to this point. Radius of the axle equals 0.003 meters. Question 3. Determine the tension in the string while the wheel is moving downward. Question 4. Calculate the angular speed omega prime as a function of the angle phi when the strings begin to unwind themselves in opposite sense, as depicted in Figure 19.6. Sketch a graph of variables which describe the motion in Cartesian system which suits the problem, and also the speed of the center of mass as a function of phi. Question 5. If the string can withstand a maximum tension Tm equals 10 newtons, find the maximum length of the string which may be unwound without breaking by the wheel.